Alright, ready to go with question 7. This is May 2015 IBSL Maths, paper 2, time zone 1. Last question from section A, last short answer one, still making time, so we've got plenty of time to finish off that section B. Let's see how we go. Following diagram shows part of the graph of a cubic. Find the coordinates of the local minimum point. Calculator exam, calculator time. Get your calculator out, you can see I've already popped it in there. What I haven't done is look at the viewing window yet, and if you have a look at this and I draw it, yeah, I can find the local minimum there. If they've given you a view, try and match that view. Just makes your job a little bit easier. So it looks like, you know, if I check my viewing window, yeah, x minimum -1, if I took that out to maybe -6, maybe if in fact, just exit that, if I just did the standard view, would that be good enough? I like the standard view. The IB people often make sure that it fits in your standard view if they don't give you a domain. So let's have a look and see how that looks. Pretty good. We just need to go a little bit higher and lower. And probably actually not. No, they seem to go about that wide. Sort our viewing window out. Let's just get, maybe send that up to 30. Just to make sure we can really include that top value. Good enough. That's a nice view. Quite comparable to what they've got. I'm ready to go. Find the coordinates of the minimum. This was an easy point. G-solve, minimum. Got it. X equals -0.3 and Y is -0.967. So, write it down. -0.3, -0.967. Done. Pretty easy. You can just write that you use your calculator for it or whatever. The graph is translated to the graph of g by the vector 0, k. Find all values of k so that g of x equals 0 has exactly one solution. Now there's a clue there that we've got to look about. It says find all values of k so that g of x has exactly one solution. At the moment this has got 3 solutions, 1, 2 and 3. Now there are 2 possible situations where it would have only one solution. Let's have a look just over on the side here what they would be. Either I shift the graph up a little bit and I get one solution right there, don't I? So that's shifting vertically. So that's for a k greater than 0 shift. What's the other option though? I could shift it down, k less than 0, until there was just one intercept on that side. Either one of those would give me a situation where g of x has exactly one solution. So the first case is pretty easy to deal with. We'll go ahead and we'll do that right now. Find where my cursor is. There I am. Okay, so if I want to shift vertically upwards, k needs to be greater than 0.967. That would result in, and it doesn't hurt for you to give them a little sketch of what it would look like. There would only be one intercept there. What about the other one? Well, we better find the coordinates of the local maximum first. The local max of f of x is, let's get our calculator back and find out what it is. Shift G-solve, find the maximum please, and it's 2,11.2. So we go ahead and we write that in. It's 2,11.2. Okay, so therefore k values. So if k is less than -11.2, because we've got to subtract 11.2 or add a negative on, k is less than 11.2, that's going to result in a graph of g of x. Let's try and draw this one a little bit neater than the previous one. Again, you've got the idea. So there's y, here's x over here. My graph is going to look like this. So there's g of x there. So that gives a value of g of x where there is only one value where g of x equals 0. There you go. That's the end of section A. Catch you in section B. Aloha.